Hey there, scholars. I wanted to do one other thing about heat energy thermal energy is I wanted to take 2 cups. This one is cold water and this is hot water. Okay, hope y'all can see the letters. Okay, so I'm going to put sugar in here and I want you to observe what happens when I put sugar in cold water. And what happens when I put it in hot water? Look very closely. I know it's really hard to tell, but I can see all the sugar just kind of moving quickly because hot water is heat and that's a lot of movement. And cold water, it's just kind of settling at the bottom. And you have to kind of stir it to get it where you want. But this like dissolved really well because hot water is like movement. It is like moving like this, you know? And cold water is very still. And so a lot of the sugar is settled at the bottom. You have to kind of mix it. And in this one, not a lot of sugar settled at the bottom. It has dissolved faster. So something to think about. And you know what? I'm curious. I want to know what happens when I put food coloring in cold water. Just 1 drop. I just want to see like how fast it reacts, and 1 drop in hot water. Look at that. Let's just take a moment to observe hot and cold water. I'm noticing the green has mixed pretty fast. Cold still needs a little bit of work, but green has mixed pretty fast. And that's because when you have heat energy, it is like constant movement. Cold water, because there's very less thermal energy, it's just kind of still. It's just calm. But then when you do this, the water is fast and actively moving. Think about like when you guys go to PE and you're all in the gym and y'all are running around like you are the molecule. And like what ends up happening when PE is over? Y'all are sweating, right? Because it's so hot because y'all are moving around. When y'all just sit in the gym, it might be cold because there's no movement in molecules.